aspect. The third aspect is to study the function of different monosaccharides or polysaccharides or oligosaccharides in different plants or in animals. This manus is monosaccharides. People don't think we study on monosaccharides function. We can publish this kind of paper, but yeah, this group studied the manus and found it quite one kind of monosaccharide have very good effect to inhibit the tumor cell growth, and they study the mechanism, and also they publish in the Nature paper, and also interesting found this paper. Also, this part is about the glycosylation function, how to the mechanism of the glycosylation function, like the receptor of the different kinds of carbohydrates, like the glycosylation of important protein, how to control its protein's function is the fourth test. This part should be the published most good paper. And also in the COVID time, they published lots of CS paper related to the SARS-CoV with glycobiology. Just like I talked before, lots of mutations are related to glycoside. Every time when the mutation, they publish some paper on this different glycoside and glycan. And also they found the glycosylation will help to promote the antibodies function. This part also very important. Not now there is no COVID-19, but this glycosylation of the antibody is also helpful to other drug development. Yeah. On plant part, I know lots of you are working on plant. On plant part, there are also several good papers related to glyco. In maybe nearly 20 years, they found the chitin receptor and published in Science. And also they found the GH, some important effects which are carbohydrate enzyme. It also can have function in plant. They also found this effect receptor and its effect also published in the paper. And in this year, they study the pectin, the PG, which can catalyze the pectin, and the PGIP, which inhibit the PG's function. Also published a good paper in Science. I also helped to do something. I offered them the pectin oligosaccharide, and I also studied the enzyme function. So I also helped to publish this Science paper. Okay, just to give lots of examples about the high good paper in glycoscience, and this is in Nature Career 2017. It's also I think like an outlook paper. Say means great success in the state in next 40 or 50 years. Both the glycan research is important for science, and also on this field they will be great for younger students. It will be lots of famous scientists and engineering in this glycoscience. Yeah. So I think still young students, you can, if you have interest, you can study on glycoscience. It will be interesting to study on protein and RNA or DNA, because these complex and lots of problems need to solve. Yeah. just 5 years after this outlook, Beethoven, I just showed before, she found the glycosylation of RNA in the Nobel Prize. But most work is not about the RNA glycosylation, it's about the clinical chemistry in glycobiology. She produced lots of different protocols which can give us direct view of the glycan in the cell, on the cell, or on the cell directly, and also can in the different reaction system. So based on this, she win the Nobel Prize. Okay, these are the background, and I will show two examples to identify the fungi polysaccharides, which is the escape is focused at that part. In this work in my label, we use this Rhizotomias solani to this. This fungi can cause the rice chest blight, which is very important, very harmful rice disease. But the cell wall of this, I call it the eyes, the short name. The cell wall of eyes is very important, but the structure is not so clear. There are no paper about the eyes in rice, but some three or four paper about on the eyes in other plant, not on rice. But all these research are not so clear. Let us to know which know the structure and the component of the cell wall polysaccharides. So follow this step in my label. One PhD student do this research. First, to collect the samples and use different extraction methods. Most are water extraction and the water alkali extraction to get 5 different components. Yeah, these are raw components. And first, we check the monosaccharide of these. There are 5, but one is similar with the monosaccharide of these different components to check which I found the glucose in most components. And then the second step is just follow to do the purification using 2 different glue, the DAE cellulose and the gel chromatography glue, the safety, and we got 5. We got 5 single peak, and use this 5 to do future identify work. These are the basic composition analysis. Found there are true sugar and true carbohydrates, not so many protein in these samples. And use GPC, HPLC to check the molecular weight, and the weight are very high molecular weight. Yeah. Also to see the detail about the structure, and this can't give more information. Just take a look, and then you different methods to first to check the spectral from to check the different monosaccharide and the link, and also do the modulation modulation analysis to check the different link. After this work, we can speculate the structure and the link of these 5 different polysaccharides from the RNA cell wall, water-soluble part. And then we also do studies its infection in the plant immunity promotion and found it have some effect. And also this one have the based effect, and we do the NMR to check the link information from the methylation. Yeah, this one HF201 is the based effect, and to use the NMR to give this detailed link information. Then we do a detailed function study and found it can trigger the plant immunity to protect the plants, and it also can promote the salicylic acid promotion with the genes upregulate. So the summary about the RS water-soluble plant cell wall polysaccharide is we purify the fiber components, and we check the monosaccharides and the different link of them, and this HF2 have a good effect to induce plant immunity. And the second part, the work is due at the same time. The second part is the water. Insoluble polysaccharide is the inner part of the fungi cell wall polysaccharide. With the method nearly the same, we check all the analysis results. And also we can give this structure we will give with the monosaccharide and the link, and also studies the effect in the plant to control the RS release with the same model, and to show the release linkage. On this part, we also check the polysaccharide effect to accumulation of the RS, which is the important plant defense signal. We found in high concentration, they can treat this RS production. And the CRT1, which is an important receptor. So because in the label we have this CRT1 knocked mutant. So we check, we use the normal plant and also the CRT1 plant. We found this RS cell wall insoluble part. It can trigger plant immunity, not only dependent on the CRT1, because in the mutant we still have some function. Yes, and also in this part, when we treat, because the CRT1 is electrical is chitin, so when we use the chitin to treat the plant first, it can be the RS first, and then we add this RSCW, cell wall polysaccharide. We found it still can treat a second peak of the RS. So it validated the formal research, found that this cell wall polysaccharide not only depend on the CRT1, it also have another new receptor to trigger the gland immunity. I don't need the summary. So, supposed to be 1 hour, but now it's 20 minutes, or 20 minutes. So, I think this talk today is background, and especially for young students, I think it just let you to know the life science research is in the ascendant, and it is a hot pot with great gains in recent years. And the natural polysaccharide resources are abundant and renewable every year. It is closely related to the real function of life. And the glycobiology research will help to build the nature's laws, and the glycoengineering research can produce a serious functional flux and energy flux, which will be very helpful for human, for the Earth in future. So it is of great significance to study glyco science. And in this part, it is significant to study extraction and identification of polysaccharide in nature, which we know the polysaccharide, we can use the polysaccharide in future, because the polysaccharide is the most biomass of carbohydrates. So in next 2 talk tomorrow, we will talk about how to use the enzyme to degrade the polysaccharide to oligosaccharide. And the third talk, we are talking about how we use the oligosaccharide to be pesticide and fertilizer, and how it's used in China. Yeah. Okay. These are two ways to fellowship to support the scientists or the young students to study in China. Because we talked about it yesterday, so I added this to slide. One is called PIFI, which is supported by CAS. It can it has several different fellowship for the senior scientists, for the young scientists, for the postdoctoral, for the students. There are different projects. They can be short one, 3 months, to long one, 2 years. I think it's a good project, and it can be called a PIFI fellow. So I think it's open 4 times every year. So if you have interest, you can check this. Another is called the answer. It's Alliance of national and international science organizations for the Belt and Road regions. And also Chile is in this answer project. This also, I think, they also support the professor and also support the PhD. But most are supported for the PhD to study in China. Yeah. This may be open 2 times or 1 time a year. If you have interest, you also can check on this website. Yeah. The last sector, all the organization they give the fund, and also the corporation companies, and second all the people, the teachers and the students in the labor. Okay, and thank you very much for your listening. Thank you. I also happy to answer questions. It's a long talk.